Welcome back to Applied Mathematics. In this video, I want to talk about properties of algebra, which, as you'll see, is a generalization of some of the rules of dimensional analysis that we've talked about previously. Let me get my head out of the way, and we'll start in with a little bit of vocabulary. We've used the idea of a variable and a variable expression previously in this course, but I do want to more formally define those things here. A variable is used to represent an unknown value. A variable expression is a combination of constants, variables, and operations. A very simple example of a variable expression might say something like 3x minus 7y. I want you to think about variables as units of measure. Right? 3x minus 7y, I want you in your head to treat the same way you would treat something like 3 feet minus 7 ounces. It's a little bit silly at first because feet and ounces are not the same kind of measurement, but let's say that we are dealing with a chain that we know the weight density. For every foot of the chain, we know it weighs some number of ounces. So that measurement, even though it doesn't look like something that would go together, there might be an application where it makes some sense, where there is a way to perform a unit conversion on it. But, right, we don't have those kinds of specifics, right? X is not a measurement, a unit of feet. X is some kind of measurement. Whatever that measurement is, we have measured that there are 3 of this x sitting over here, and we're taking this other measurement of y, and we're taking 7 of them, and taking them away from that measurement in terms of x. And with those ideas in mind, we can use the same sorts of dimensional analysis rules in order to work with our variable expression that we could with just some measurements. Getting a little bit ahead of myself. In the study of algebra, we generally use as one of our basic units terms. Terms are things being added or subtracted. In this simple expression, we have 2 terms. 3x is a term, 7y is a term. When we look at a term, we can quickly identify the variable factor and the coefficient, which is a fancy name for the constant factor. Right? Looking at this in that expression, I might say something like the coefficient of the x term is 3, and the coefficient of the y term is negative 7. I would never write that out, but that might be something I say about my statement. Two terms are called like if they have identical variable factors. Otherwise, they are called unlike. In the example I have on the screen here, 3x and 7y are unlike. An x term and a y term are not the same, just like feet and ounces are not the same. Right? In this expression, 4x plus 11x, these are like terms. There are two terms. 4x is an x term. 11x is also an x term. In this expression, 4x plus 7x squared, these terms are not like. 4x is an x term. 7x squared is an x squared term. Remember, x squared means two factors of x. These are not like terms. We won't be able to work with them. We like having like things. I hate that that word uses, or that sentence uses the same word for two different meanings. We like having like things because we can do operations on them. We can combine like terms by adding their coefficients. That is one of the two big ideas in this lesson. So if I have 4x plus 11x, these are like terms. The coefficients are 4 and 11. I can add 4 plus 11 and get 15. No, you don't have to write that middle step out, but seeing it written out might help you understand what I'm talking about if it's been a while since the last time you have thought about combining like terms. Let's look at a slightly more complicated example. 9x plus 4y minus 7x plus 2y. One of the things you really have to pay attention to in this expression is the subtraction that is happening right here. Subtraction makes things difficult in algebra. We mentioned at the beginning of this course that subtraction is really addition in disguise. And for that reason, it is often better to rewrite subtraction as adding a negative number. That will allow algebra to do its thing a little bit better. Once again, this is not necessarily a you have to write it down. When you are comfortable working with combining like terms like this is something you can do in your head very easily. But if it's been a while, or you've had trouble with these sorts of things in the past, or you're just not quite comfortable, write that extra step out. It will save you from making mistakes so many times. I speak very deeply from personal experience. But now that I have done that and everything is addition, I can use the commutative property to rearrange these two terms in the middle. so that 9x and negative 7x, then add 4y and plus 2y. Right? The commutative property of addition says that we can reorder the terms of our addition without any issues whatsoever. Then the associative property of addition says that we can add some grouping symbols. Group these things together, group those things together. And by doing that, we have isolated some like terms. 9 plus negative 7 is 2. 4 plus 2 is 6. 2x plus 6y. All right, one more example here. Three minus 5x plus 7x squared minus 9 plus 5x squared. This one is starting to get complicated. There are three types of terms in this expression. There are x squared terms. There's two of them. I'm going to identify them and bring them to the beginning. 7x squared and 5x squared. Next up, I have this 1x term minus 5x. And then finally, I have two constant terms, 3 and minus 9. So plus 3 minus 9. I've rearranged everything. Technically speaking, this is several steps of using the commutative property, just over and over again, swapping things around until everything gets where you want it to be, but you can do it all in one step. I encourage you to use some strategy like what I just did here of underlining things, right? We find all of our like terms for one type of term. We will mark all of them by underlining them to remind ourselves that we've used those ones as we write them down. We'll do the same with the next set and the next set until everything is underlined. That way we can double check that we haven't lost anything, we haven't duplicated anything, and we can triple check by counting that there were 1, 2, 3, 4, 5 terms in the original expression, and there are 1, 2, 3, 4, 5 terms in the new expression. All of those things helped us make sure that nothing strange has happened. Now that we've done that, we can group together these terms. We can group together these terms. I mean, I guess technically we can group that together, but there's only one thing there, so why bother? And we can combine our like terms. 7x squared plus 5x squared is 12x squared. And 3 minus 9 is negative 6. Last thing to notice on this one, right, there is that squaring going on, but remember that that squaring is on the x, not on the coefficient. So 12 is not being squared, x is being squared, there's nothing else we can do. This is our simplified expression. There's a lot more that we can do with simplifying expressions. We're going to be revisiting this idea throughout the rest of the course, but for right now, I think that's a good place to stop. So thank you as always for joining me, and I'll see you next time.